In this video, I'm going to start talking about circular motion. So one of the things that we have to remember back to is initially when we started talking about vectors. What is a vector? A vector is something that has magnitude and direction. Okay? And the definition of acceleration is when you have a change in the velocity, and velocity is a vector. Okay? So there's three different ways in which we can accelerate some object going at some velocity. We can slow it down, we can speed it up, but we can also turn it. Okay? So when something is turning in a circle, you can see that that would be, let's say we're right here, this instantaneous velocity, that would be my initial velocity tangent to the circle at that point. And then over here, I have a final velocity, and even though the magnitude or the length of the vectors is the same, or the actual speed of the vectors is the same, because they are changing, okay, they are turning, we're still accelerating, okay? Now, we can pick vectors up and we can move them around in space as long as we don't change how big they are in their direction. So that's what I'm going to do here. I'm just going to move this vector over here. And you can see that the difference in the acceleration, or the difference in the velocity, is from here to here. So that actually is our change in velocity, or our acceleration. Okay? So centripetal acceleration is what we call it when you are accelerating by turning but maintaining a constant speed. And in order to calculate this, we say that centripetal acceleration is equivalent to the velocity squared divided by the radius of the turn, or the radius of the curvature. Okay? Well, now that we have a centripetal acceleration, we also can have centripetal forces then that cause something to turn. Okay? So again, this is just using Newton's second law down here. We have F net, or centripetal force in this case, is equal to mass times centripetal acceleration, okay, which would be mv squared over r, okay? So this force is any force that is holding or causing an object to turn, or holding an object in a path where it's curving, okay? Centripetal means center seeking. It always points towards the center of the circle, or the center of the turn, okay? So whenever we solve a problem where something is turning, we really have to ask ourselves, the centripetal force is what is causing the turning, okay? And we'll look at that here in a minute, okay? So if we look here, if I take a tennis ball and I were to spin it around on a string, okay, what is causing the centripetal force? What is causing it to turn? Well, in this case, we would say that it was the tension in the string that was causing it to turn. Okay. And we'll look at some other examples where we have to think of what is the cause of the turn. Okay. Now, you may have heard of a term centrifugal, and we kind of mentioned this in the frame of reference video. Centrifugal is not the correct force. Okay. Now, remember, we said that when you are in an accelerating frame of reference, or frame of reference in which acceleration is occurring, then we can start to experience what we call fictitious forces. And centrifugal force is an example of it. So really what it is it's the feeling that you want to travel out when you're spinning around in a circle. Okay, so think of when you're going an off-ramp, or when you're turning on a roller coaster, when you're merry-go-round and you want to fly off. Okay? So your brain sort of tells you that you want to fly to the right, right? But this actually is not correct, okay? The actual direction that you want to go is to continue on your path. This is Newton's first law. So if you're going around in this circle like this, right here you want to continue forward, you want to continue straight, and the something is causing you to turn with an inward force, okay? And if you're sitting in a car, that might be like an arm, like the door pushing on you, causing you to turn. Or if you're on a merry-go-round, you're sitting on a merry-go-round, it might be the friction between you and the merry-go-round. But really, what you would want to do is you would want to fly tangent to the circle, not fly straight off the circle. So centrifugal force is a fictitious force. Centripetal force is the inward force. Alright, so we have the idea of escape velocity. This really means that at some point your velocity can get so fast that you overcome the centripetal force. So let's just go back and look at up here at one of these, this math equation here, okay? So really what this means is if your velocity gets so big that the centripetal force cannot hold it anymore. So this term would get bigger than this term. And typically there would be some limitation to the centripetal force. Like if in this example, the limitation would be the string. At some point the string would snap. Okay? In this example, if you're sitting on a merry-go-round, at some point you'll overcome the amount of friction. There's only a certain amount of friction that happens between you and the surface. Okay, so we call this escape velocity. And typically we refer to that in terms of like orbiting satellites or something like that. So think about if you're a satellite and you're going around the Earth, the force that's holding you to the Earth is gravity. So if your velocity gets large enough to overcome the force due to gravity, then you can escape the gravitational pull of the planet. Okay? Now, if you are to escape or you overcome that force by becoming fast enough, the moment you release, you will fly tangent to the circle. Okay, so that's important to remember. You'll fly tangent to the circle at the instant in which you overcome the force. Right? So another example that I want to look at is an off-ramp. So when you get in an off-ramp, there's a curve, okay, and it gives you the safe speed, right? Because you don't want to reach the escape velocity. So think about what is causing you to turn when you're in a car. Yes, you turn the wheel, but it's really the friction between the tires and the ground that make you turn, okay? And friction is relative to the coefficient of friction between your tires and the road, okay? So it all depends on your tires, the grippiness of your tires, what kind of road you're on, and also the weight of your car, okay? So if you're going too fast, then you can sort of slide out of that turn or reach the escape velocity out of that turn, right? So if we wanted to draw a free body diagram, okay, so this is the car and it's going around a curve. It's going to have the force due to gravity down, or the weight of the car down onto the pavement. It then has the normal force in response, and it has a friction force inward or into the turn. So if you ask yourself the question, what is causing the turning, or what is causing the centripetal force, it would be force due to friction, okay? So force centripetal is force friction. So we could set the equation for friction, which remember is mu Fn, which is also mu Fg, which is also mu mg, and that would be equal to your mv squared over r, or your centripetal force, okay? So we're always thinking, unless we're told a Newton value for the centripetal force, we're thinking what causes the centripetal force and how can I calculate it and set it equal to mv squared over r. And then again, I could algebraically manipulate this equation. My m's would cancel. And so the maximum velocity that you have going around in a circle that's held, whose cause of the centripetal force is friction, is the square root of the coefficient of friction times the radius times gravity. And we'll do a bunch of different examples with this style problem.